Well, hello everybody. Welcome to Code While. In episode 006, a JSON stringifyTable function, JavaScript function, was established in order to display JSON in a sort of a tabular format. Well, in this episode, we'll explore some new code while leveraging that code from episode 006. So over here at the top right of the page, you can see a QR code. If you scan that QR code, you'll reach this same web page that you can follow along if you like. That's the QR code over here. All right. So down here, I've pasted in the code from episode 006, but since that's covered by that video, I'm going to skip past it. The long and the short of it is we get this window.notQuiteJSON utility object, which has some functions in it, including the stringifyTable function. I'm going to scroll past all of that. And down to here, that gave me an object. All right, now I've got some new code here. This code is going to establish window.html document utilities as an object. And I've used an anonymous function, and I'm going to return an object. This starts an expression here, and then I'm just returning an object. It's going to have some properties. The first property is closures, and it's just an empty object for now. The next property is called isPositiveInteger, and it is going to be a function with the same name, isPositiveInteger, taking a number object. And what does this do? Something very simple. It checks if the type of the number argument is a number, and if it's finite, and if the number is greater than 0, if it's positive, and if the number divided by 1 has no remainder, then this is going to be a positive integer. So it returns true or false. The next property is called serialize HTML document as columns. Now, using a columnar paradigm might be foreign to some folks, but I'll probably make another video about the columnar paradigm and thinking about data in terms of columns. But I won't get in depth about that in this video. Just a heads up that it might seem a little strange. Sometimes you make objects and each one of them has properties, but in this case I'm going to take those properties and I'm going to make arrays of those properties and use the indices of those arrays as a sort of an ID for the objects or the pseudo-objects that are under consideration. All right, so there's a wealth of variables here. All subnodes count, empty array, ij, names, node, nodes, parents, paths, res for result, subnode, subnodes, types, and values. And the argument to this function is called doc for document. First thing we do is check that doc.nodeType, if it's not a number, then this is not going to work out. Nodes should have this node type property, and it should be a number. So if it's not, we throw an error. And next, we do some initialization. Empty array is just going to be an empty array. It'll always be an empty array. Nodes is going to be an array where we pass in doc as the first node. This nodes array is going to be our to-do list that we're processing. Right now, it's only got a single element at index 0, but it's going to have elements added to it as we process through and find more and more nodes. They'll be added to this array, and we'll process each one of them. Parents will be an array, and for this topmost element or node, it has no parent, and so I've put null into the 0 position. Similarly with paths, the path is going to be noted as a string with a 0 in it, because 0 represents the index for this element. Then I also make a all subnodes array, and it's empty for now. Then I is going to be the iterator for iterating over the nodes array, the elements of the nodes array. The first thing this loop does is it fetches the node, and for the first iteration that'll be the doc node. Then it makes a subnodes array that starts out as empty. And then it also pushes that subnodes array to the all subnodes array, which you'll remember from up here is empty to begin with. So this will add at index 0, it'll add this subnodes array as a subarray. All right. And all nodes in an HTML document can have different types as specified by the node type property. And one of those types for elements in particular are attributes. So I'm going to check if node.attributes is an object, and if it's not null, then we'll assume that there are some attributes for this node, such as for an element node, and we'll do some processing of those attributes. So I'll get a count of node.attributes.length. I'll check if it's a positive integer, because that's the only thing that makes sense in this context. If it is, then we'll iterate over each one of those attributes here with the j as an iterator. While j is less than count, we'll fetch the jth attribute from node.attributes, and we'll store that to a subnode. We'll check that the subnode, if it's not equal to an object, or if it's equal to null, or if the type of its node type property is not a number, or if the subnode.specified property is false, then we'll skip this. We'll continue on to the next attribute. Now this subnode.specified, in at least one old web browser, this actually will be false if the attribute has been either inherited or is a default value, but it'll be true if it's been specified on an HTML element. One example of this might be the calls property for a text area, for example. If it isn't specified for the HTML element, then it'll still appear perhaps in these node.attributes, but its specified property will be false because it hasn't been specified. But if it is specified for an element, then this should be true. And we only want to process attributes for elements where it's been specified in the HTML. So that's the rationale for that. And what do we do here? Paths is an array, and so we take the path of the current element. For the first iteration, that's the doc element that we're working on, and its path, if you'll remember, is the string 0, and then we add a slash, and then this nodes.length here, this is a little shortcut to getting the index of the next node that's going to appear in the nodes array, because for the first iteration, the array is only one element long, and so nodes.length is going to give a 1. So for the first iteration, it would be 0/1 would be the path. And then we take that path and we push it onto the paths array. Because the paths array already has an element for the doc node, then this is going to push a second element into the paths array. That'll be 0/1, for example. Then down here, use the same shortcut here. We know that this is going to be 1 for the first iteration, and we push that onto the subnodes array. Now the subnodes array was empty. So now we're populating the subnodes array, and that's for the current node that's being processed. We're populating it with at least this new element. Nodes.length is going to be a 1 for the first iteration. And then finally, after using that shortcut a couple of times here, we're going to push the new subnode, this attribute subnode, onto the nodes array for processing on a future loop, a future iteration. And then we also push onto the parents array, we push the current node as the parent for this node. So parents had one element to begin with, it was null for the doc, and now we're going to push 0 as the index for the parent in the first position. So what does that mean? It means the element with index 1 in parents is going to have a value 0, meaning its parent was 0. All right, well, that's what all of that does here. So after we process all of the attributes, subnodes, then we go and look at the other subnodes. So nodes also have this first child property, and they also have this next sibling property. So we set subnode equal to node.firstChild, and while the subnode is an object, while the subnode is not equal to null, and while the subnode.nodeType is a number, which means it's a node, or implies that it's a node, then we'll perform this loop. So on the first iteration, subnode is the first child, but after the first iteration, we'll walk through the list of subnodes, and that'll be by using this subnode.nextSibling value, which will give us the next sibling of the subnode. So while we walk the subnodes of the current node, we push the path of the subnode, and that's built up the same way as it was for attribute subnodes. And similarly, we push the subnodes onto the list of subnodes for the current node, just like we did here. This is all the same here. Then we push the subnode onto nodes because we're going to process it in a future iteration. And then we push the parent onto the parents list here. All the same stuff as for the attribute subnodes. It's just two sort of categories, I guess you could say, of how to access subnodes. One by attributes and one by this other first child next sibling technique. Now, after all of that, here's a little sort of a memory optimization. It's not strictly necessary, it's just a trick. This subnodes is set to an empty array up here for every node. Well, that's going to result for if we have a wealth, an abundance of nodes that don't have any subnodes, that's going to be a lot of empty arrays. So all I've done here is a tiny little optimization. I check if the subnodes array is still 0 by the time we've finished all of this logic here. I'm going to reset the all subnodes element for this position, the current node's position, to this empty array. And that'll mean that all of those empty arrays will reference the same object, and all those other empty arrays will be garbage collected. They can go away. It's just a sort of a micro optimization. That probably isn't a great cost, but why not? All right, down here, after we've done that first bit of logic here, we'll have populated the nodes array, hopefully with every node in the HTML document. And we've gleaned some information, some detail about each one of them. So now down here, I'll take the count of our findings there, all of the nodes that we processed. I'll make an empty array for the names identifier, an empty array for types, empty array for values. All of these will be empty arrays. Then I is going to be used to iterate over all of the nodes once again. This time, we'll fetch the node. We'll take its .nodeName property, and we'll push that into position in the names array. So this will correspond to the I index that we're doing here. So for the first iteration, the first element was the document element. So its node name is going to be pushed into the 0th position, the 0th element of the names array. Likewise, node type will get pushed into types, node value will be pushed into values. And that'll happen for all of the nodes. And then finally, we're going to return some results here. This result is initialized to an object, and that object has all of the names as a property, all of the paths, all of the parents, all of the subnodes. This all subnodes is going to be just called subnodes. It's an array of arrays. And then all the types, all the values, and we finally return that result. So what have we got here? The result is sort of a columnar approach. All of the details about all of the nodes in the HTML document are now using arrays and indices for each node. Each node will have a unique index, and across these arrays here, that index will refer to the particular property that we're interested in, the name, the path, the parent, etc. All right, so after having done that, there is a serialized HTML document as table function, and this is what will leverage the code from episode 006, which displays JSON in a lined up fashion so that the columns have a width and you can see with your eyeballs all the detail, and you don't have to fight with your eyes darting around, looking around to make sense of it all. All right, what does this do? It's got two variables, serialized and table. It takes a document as an element. And the first thing it does is it utilizes the function that we just explored, serialize HTML document as columns. It calls that function with the document, and it stores the result as this serialized variable here. And then we build up a table. So this table is going to be an array of arrays, and it's going to represent rows as the first dimension of elements, and columns will be the second dimension of elements. So the first row in this table array is going to have just the strings index, parent, path, type, name, value, subnodes, and you'll probably never guess what those will represent here. Then what do we do here? We're calling each node with 0, and 0 you'll remember from the previous function, that represents the document element. So I'm calling each node with 0 as the index. And then after that, we return the table object with whatever has been populated. In between here, we've got the definition of the function for each node. And it takes node as an argument. For the first iteration, that'll be 0. It's got a couple of variables, I for iteration and subnodes. And what is it going to do? Well, it's going to do a push to the table array, and it's going to push a row that has the node, which is the index of the particular node. It's going to push at that index. It's got a parent, so it's going to push serialize.parents at that index of the node, serialize.paths at that same index, types, names, values, and subnodes. All of these are going to be pushed into these positions in the new row. And then down here, the subnodes variable is going to be set to the subnodes of that index, and will iterate over each one of the subnodes with the I index as an iterator, and we'll recall this same function, we'll recurse. We'll call this same function for the subnode, and this will wind up walking all of the nodes, even though we just started with just the document node. This is going to recurse. All right, so that's what that does. And here's a setup function. This property is a function called setup, and all it's going to do is establish some closures so that these functions can be called without having an object, so that they can be called without being members of an object. So I make an underscore variable. Its name isn't that interesting, and I assign this to that underscore. Then you'll remember up above we had an empty object called closures for this object. So now I'm going to populate it. I'm going to take this same name, serialize HTML document as columns. I'm going to make a new function whose name is closure underscore serialize HTML document as functions. And this is just simply going to return, taking the underscore dot serialize HTML document as columns. It's going to call that function with the apply technique. It's going to pass the underscore, the this, to that function as the this property that's available in that function. And it's going to pass the arguments that this closure was called with. And the same thing for serialize HTML document as table. What is this doing? This is just capturing this object, this main primary object of all of this code. It's capturing that as this, making it into an underscore, and making little closures to be able to pass that along as the this property for those functions when they're called. All right, and then finally we return an object. We return an object, and it's just going to have two properties, and those are going to be the names of the two functions, and they'll have the values of the two closures that were just established. All right, so that ends the object. That ends an expression. That was an object expression, and we call the setup function on that object, and that'll execute all of this. And then all of that was returned at the top of this function. We returned the result of all of this, and that was the end of the function. the end of the expression that made that a function expression, and finally we call that function to get all of this to happen. All right, so what did we get from that? We got an object. All right, well, how do we use it? Okay, let me paste something in here. All right, what have I got here? Oops, let me click over here. Here we've got, I've just spread it out so that you can see it here, window.notQuiteJSON, and we're going to call the stringifyTable function. That was from episode 006. And what are we passing here? Window.html document utilities .serialize HTML document as table with document as the argument. So all of this is going to go through, it's going to chop up all of the nodes into columns, and then this function will take those columns and process them into a sort of a tabular format with columns and rows, and then we'll stringify that table. So what do we get? Let's click eval. Oh, it took a moment. Pardon me. And what do we have here? Okay, so there's an array. This is some JSON. All of this is JSON. There's an array, and the first row looks familiar. This is an array, has column names, index, parent, path, type, name, value, and subnodes. And then this is the first row. This should be the document element. Its index is 0. It has no parent. Its path is 0. Pardon me. Its type is 9. Its node name is Octothorpe document. And its value is null. And it has 2 subnodes, 1 and 2. All right, here's 1, element 1. Its parent was the document at 0. Its path is 0/1, 0/1. Its type is 10. Its name is HTML. Its value is null, and it's got no subnodes. 2, HTML. 3, head, some text, meta. And we can follow along, and we can see this is sort of giving us a combined tabular, and maybe these paths give us a sort of a tree view, and we can kind of see what all of the different nodes in the HTML document are. This is the title. That title was an element. It had some text. The body. This div is a subnode of the body, and so on. On-click attribute, p element, ID attribute, text, pieces, on-click attribute, and so on. Well, I hope you enjoyed that, and I'll hope to see you rejoin us in another CodeWhile episode. Us being web pages and me. Take care, everybody. Goodbye.